Okay, as promised, more examples. I got 5 examples in this video. So let's start with the first 3. The first 3 are on this page. Number 1, solve for y. If z equals 2xy. Okay, again, I'm not going to get a solution like y equals 10 or y equals some number. Right? It's going to be in terms of the other variables because I don't know what x and z are. Okay, so let me rewrite the equation below so I got a little more room to work here. Solve for y. Z equals 2 times x times y. Right? And it's important to realize we got multiplication going on because I need to know that in order to solve for y. I need to get rid of the 2 and the x. Okay? So you always have 4 options for these. Add, subtract, multiply, and divide. If I realize that this is multiplication that's happening here, then I need to undo that, and I undo that by division. So if I divide this right-hand side by 2x, then that's it. That's all I got to do. That'll give me y by itself, right? Because 2 divided by 2 is 1, x divided by x is 1. That leaves me with 1y or y by itself, which is exactly what I want. But if I divide the right side by the right side by 2x, then I have to divide the left side by 2x in order to keep equality, right? Which you've learned before. And that was a fairly easy example. Okay, I can do it in one step. Y equals z divided by 2x. Okay, how do I know I'm done? Well, if I've done everything correctly, I'm done when I have y all by itself, right? Because that was the goal, to get y by itself. Alright, moving on. Example 2, solve for z. X equals 7y plus z. 7 times y plus z. Okay, solve for z. So I got to get this guy all by itself. Alright, so I have a couple options here. But what I'm going to do first is get rid of parentheses. Typically that's what we do first. Okay, in other words, I'm going to distribute the 7. Okay, I want to do that, distribute that through, so I don't have parentheses anymore. So x equals, nothing with the x yet, 7 times y plus 7 times z. Okay? Again, the goal is to get z by itself. So before I get rid of this 7 that's attached to the z, I got to get rid of this whole y term. Okay? Follow my process of algebra, and if it's added to the z term, then I'm going to have to subtract it, right? It is added to the z term, so I'm going to subtract 7y from both sides in order to get the z term by itself. I won't be done, but I'll have a z term. I'll have 7z. Right, that cancels that out. So over here on the right side, I'm left with just 7z all by itself. And on the left, it should say x minus 7y, which I can't do, right? I can't subtract that because x and 7y, they're not like terms, so I just got to leave it like that. Okay? Now you're one step away from the solution to get z by itself. It's 7 times z, multiplication happening here, so we need to undo that by division, right? So we divide by 7. Both sides by 7. And then I'm done, right? So z equals, there's options to write your answer for this one. I could divide x and 7y by 7, but I recommend just leaving it like this, right? You get the same answer. Same solution for z. This one is one less step. What I'm explaining is I can take 7 into both of these terms and write my answer as x over 7 minus y if I want, but I'll just leave it like that. Okay? Alright. Example 3. Solve for x. 4x minus 9y equals 36. This should look maybe a little familiar to you. This is the equation of a line using the typical variables x and y for your input and output variable. So I want to solve this thing for x. So it's very similar to what we did over here in example 2. I need to get rid of the y expression first. So I'm going to add it to both sides. Right? In this case, add because it's minus 9y, so I got to add it to both sides in order to get rid of the y expression. Okay, so that's gone. So it leaves me with 4x equals, and on the right side again, I can't add the 36 and 9y together, so I just do the best I can. 36 plus 9y. Okay. Trouble with my y's. 36 plus 9y. Okay? And I'm one step away. Divide by 4. Very similar to the previous problem. Really one less step than the previous problem. x equals, right, because the 4 cancels out, and again I'm allowed to leave my answer like this, 36 plus 9y over 4, because, why am I allowed to leave it like this? Because 4 doesn't go into both of these numbers. If it did, then I could go a step further. That step would look something like this. 36 over 4, I can divide that, I get 9. But the answer is not 9 plus 9y. I see that mistake a lot. It would be, if I take 4 into this one, then I get 9, but I got to take 4 into this guy, which I can't really do, so I have to write it as a fraction. Okay, and I get that solution for x. Either one of these is acceptable. Okay, just be careful though. If this happened to be an 8, then I can take 4 into both of these. Then I got to go a step further. Okay. All right, that's 3 examples. Let's go 2 more in this video. Call this example 4. That's a 4. Okay, and I call this example 5. And the same idea here, only I got fractions. Okay, but don't be scared of fractions, because what we're going to do is kill those fractions right away. If I have, let me rewrite this, a equals d plus e over 4, and I want to solve for e, I got to get e all by itself. But regardless of what I'm solving for, in example number 4 and example number 5, I'm going to get rid of the fraction first. That's always what I'm going to do. Anytime I see a fraction, get rid of it. I don't want to deal with the fraction. And we might remember how to do that. Multiply both sides by the least common denominator. In this case, there's just one denominator. It's 4. So multiply both sides by 4. Why do I do this? Because that cancels out, right? If I multiply by 4, you can put it over 1 if you want, just to see this is up top, this is in the bottom. They cancel out. Okay? So why did I want to do that, and why did I tell you to always do that? Because look what I have now. I don't have any more fractions. D plus E on the right side, and on the left side 4 times A. That's a 4. Okay? So right away it's easier. Now I'm one step from the solution. 4 times A equals D plus E. How do I solve this for E? Well, I got to get rid of the D. So which operation do I do? Add, subtract, multiply, or divide. It has to be subtraction, right? Because at this point it's added to the E. So you got to undo that, so you got to subtract. And if I subtract D from the right hand side, then of course I have to subtract it from the left hand side to keep the equality. That gives me E by itself. And over here that's not 4A divided by D, it's 4A minus D. So just be careful how I wrote that. I put it underneath, because that's typically what you do, but here's how you write your answer, because you can't subtract, again, you can't subtract D from 4A, so you just write your answer like that. 4A minus D. Okay? One more, D equals M over V. Solve for V. I don't care what I'm solving for really at this point. Once I see there's a fraction, always get rid of the fraction. Right? Just like in the previous example, I'm going to multiply both sides by the least common denominator. In this case, there's only one denominator. So I multiply both sides by V, just like I did in the last one. Why do I do that? Because those V's cancel out. Okay, so in one step I have V times D equals M. V times D equals M. Okay, it's a V. Let's try that one more time. V times D equals M. Okay? Now, in order to get rid of, again, I always want to keep in mind what I'm solving for. I'm solving for V, so I got to get rid of the D. What do? Add, subtract, multiply, or divide. Because it's multiplication going on here, I got to divide, right? Divide both sides by D to get V by itself. And then my final answer should look like this. V equals M divided by D. And then I'm done. Okay? Alright, so I hope that helps. Keep studying. Now you got to practice a lot of these and do a lot of homework.